All right, 3.1 day 2 also involves solving inequalities. That's kind of a theme through the whole chapter. But today we're adding the element of inequalities that contain the absolute value operation. Really 3 cases that we have to think about with absolute value. I think it's best if we kind of represent these cases on a number line. We're using the arbitrary reference point of C. And the reason I like looking at the number line is because the definition of absolute value is a number's distance from 0. Okay? So notice I'm marking C and negative C, because whatever that value is for C, there's one other number that has this exact same absolute value, and that's negative C, because it's on the opposite side of 0, but the same distance from 0. Okay, so if we have an equation that has absolute value of something set equal to C, the way we'd graph it is to mark the point C. No interval or anything, just mark the point C. And mark negative C. Okay, no intervals or anything like that, but those are the only 2 numbers that have an absolute value of C. If we see a less than sign, we are talking about all the numbers that have absolute values less than C, meaning they have a shorter or a smaller distance to 0. Well, that would be all the numbers here and here. Okay? We're saying the numbers we're looking for as our solutions are no farther away from 0 than C and negative C. If it says greater than, it's the exact opposite. Okay? We would split it up as 2 inequalities. One saying that x is less than negative C, so all those numbers that are highlighted down there, they're farther away from 0 than negative C. And greater than positive C, because we want all the numbers there that are farther away from 0, which again is right here, farther away from 0 than C. As always, it helps to look at a few examples, which we will. This can look a little bit confusing, but understand this. It's saying the exact same thing as we just saw, except now instead of x, we're saying we could have a linear expression inside the absolute value, and you'll see that if we just replace ax plus b in for x, like we saw on the previous slide, all the same things hold true. Okay, you'll see the same structure that if we have an absolute value that's less than C, same thing. Excuse me. Same thing if it's greater than C. All right, let's look at these, and as always, let's put these on a number line. Alright, so I've got 1, 2, 3, I'll go up to 5. I'll have -1, -2. Looks like I'll need a little more space over here. Okay, so I would mark 2 points here, one of which is 4, because the number 4 has an absolute value of 4. So does -4. Okay, those 2 points, 4 and -4, those would both be solutions. I could take the absolute value of 4, that's 4. I could take the absolute value of -4, that's also 4. Those are the only 2 solutions. Okay. Absolute value less than 2. Again, this will change to an interval where x is greater than -2 and less than 2. Okay, notice here I have a less than sign. And the significance of that is I only want the numbers that have an absolute value less than 2, meaning their distance from 0 is less than 2. Okay? On each side of 0 on my number line, I'll go to 3 and -3. Here's 2. Here's negative 2. Okay, and again, I just want the numbers that are closer to 0. That would be everything that's in here. All right. Notice the number 3 isn't highlighted. The absolute value of 3 is 3, which is bigger than 2, which is why I don't want it. I could pick any number on that interval that's highlighted in red, and their absolute value would be less than 2. All right, so these are the ones where we have a little bit of solving to do here. Again, I'll get our number lines ready to go so we can graph these solutions when I have them. Be a little bit of work here to get them. All right, again, I want to convert this to a different inequality that does not have an absolute value, and this is the key. This is a less than, okay? So I want numbers or quantities. Now, it's not just relative to 6 because I have this x plus 3 thing going on, but I'm talking about less than, so I would set this up so that x plus 3 is less than 6 and greater than negative 6 because I want it within that particular interval. Okay, now it looks like it's kind of a funny one to solve. To get x by itself, I'd minus 3, and I need to do that to both sides on my inequality. So I will get that x has got to be greater than negative 9 and less than 3. Okay, I'll graph that one in just a minute. But to contrast that one, here's a greater than, which means I have to split this up as two different things. Okay, I can say negative 2x minus 4 has to be greater than or equal to 5. That'll form one boundary of solutions. The other one would be negative 2x minus 4 has to be less than or equal to negative 5. Okay, this is one where you'll see that I want the numbers that are just farther away from 0 than a certain point. Okay, so here I'd have to go through and solve these two inequalities separately. Okay, I need to solve them separately. This one you would see will be x. Go ahead and solve this one on your own. For the sake of space, I'm going to skip over the work. The inequality will change directions because I will eventually divide by a negative. Okay, so that's one interval of solutions. X less than or equal to negative 4. This one will also change directions. X greater than or equal to 1/2. Again, if you need to take a little more time to work those through, feel free to do that. Now back to graphing here. All right, this was a less than, so again, this should be an interval of numbers from negative 9 to 3. Just to make the numbers a little easier, I am going to go in multiples of 3 here, so I can more quickly get down to negative 9. That forms one boundary, so does 3, and I want everything that's in between. Okay, there would be my solutions. Everything from negative 9 to 3. All right, here, I'll start at 0. I have to extend this one a little bit. Because I do need to include negative 5, so I can use the reference point of negative 4.5, which would be right here. Okay, now I'm going to close that because I should include the point 4.5. All right, but I want everything that's less than 4.5. All right, so negative 4.5 or less. Then I do 1/2 or greater. Okay, notice it looks the exact opposite as the other one, where it was this interval and all the points. Yeah, this interval was formed by marking my two boundary points and then shading in between. And here it's the exact opposite, where I've got these two boundary points, okay, negative 4.5 and 1/2, but I shade the outside instead of the inside. And the reason that's the opposite, this was a greater than sign, that was a less than. Okay, and that's how those work with inequalities. All right, make note of any questions that you have, and we'll talk more in class.